Hi there, this is orbit questions, including geosynchronous orbit for A-level physics. So, before you answer these, obviously, at school or in a different video, you would have to have learnt about Newton's law of gravitation. So, these questions are an application of Newton's law. So, if you want to pause the video and have a go at this one. So, first one is calculate the expected orbital period of the moon. And it gives the moon's orbital radius, the g, the constant. And with that, you'll be able to answer this question. So whenever you get an orbital question, the go-to is the gravitational force, the g m1 m2 over r squared, being equal to the centripetal force. The reason we can do that is because the gravitational force is responsible for the moon to exhibit circular motion around the Earth. So what we're saying is that the gravitational force on the left is equal to the centripetal force on the right-hand side of this expression. So straight away the masses cancel, the r's cancel, and we're left with v squared is gm over r. Now, we don't know v, but we want the time period t, the orbital period, so we need to eliminate v. So there's an equation from further mechanics, which is velocity is 2 pi r over the time period. So if we square that and substitute it in, so we'll be left with gm over r equals, and then square this, so 4 pi squared r squared over t squared. Then rearrange to get time. So t squared is equal to 4 pi squared r cubed divided by gm. So we just need to plug our numbers in. So t would be equal to the square root of 4 pi squared times the radius cubed, so 3.8 times 10 to the 8 cubed divided by gm. So that's 6.67 times 10 to the minus 11 multiplied by the mass, which is the mass of the Earth, which is 5.97 times 10 to the 24. If you put that in your calculator, you'll get a time period of, so we get 2.3 times 10 to the 6 seconds. If you divide that by the amount of seconds in a day, which is 86,400, we get 27 days. Okay, let's move on to the next one. Hopefully that's okay now. So on this one, you can attempt this if you wish. We need to calculate the height above the Earth, above the surface of the Earth, for a satellite to undertake a geosynchronous orbit. Remember, geosynchronous orbit is where the satellite would have a time period of 24 hours. So once again, the go-to for orbits is the gravitational force, the gm1 m2 over r squared equal to mv squared over r. Cancel the m's, cancel the r's, and then we need to substitute in for v to eliminate v, same as last time. So v is equal to 2 pi r over t. So square it, make it equal to gm over r. So gm over r is equal to 4 pi squared r squared over t squared. And this time rearrange to find r cubed. So take that r up, so we end up with r cubed is equal to, so it's gm t squared divided by 4 pi squared. So r is the cube root of, so g 6.67 times 10 to the minus 11 multiplied by the mass, which is 5.97 times 10 to the 24 kilos multiplied by t squared, So the time period is 24 hours. If we multiply that by 60 seconds and 60 minutes, we get 86,400 seconds. 86,400 seconds. And remember, we need to square that. And then divide that by 4 pi squared. Remember to do the cube root. And that'll give us the distance from the centre of the Earth. So that's the orbital radius. That's 4.2 times 10 to the 7 meters. So to get the height above the surface of the Earth, we need to take that value and subtract the radius of the Earth. So 4.2 times 10 to the 7 and subtract the 6.37 times 10 to the 6. So that gives us a height above the Earth of 3.6 times 10 to the 7 meters. So that's our final answer. Hopefully that went okay. Let's have a look at the final one. So final question for you to attempt. So if you want to have a go at this. So the Hubble Space Telescope was launched in 1990 into a circular orbit near the Earth. It travels around the Earth once every 97 minutes and has a mass of 1.23 times 10 to the 4 kilograms. Calculate the following. So first of all, the angular speed. So angular speed is an equation from further mechanics. So omega is equal to 2 pi over t. So 2 pi divided by the time period in seconds. So 97 minutes will be 97 times 60. So that gives us an angular speed of 1.08 times 10 to the minus 3 radians per second. So height above the surface of the Earth, we can do the gravitational force, G m1 m2 over r squared, equal to the centripetal force, but this time instead of mv squared over r, we're going to use the mr omega squared version. So the masses cancel. And if we rearrange, we get gm divided by omega squared would give us r cubed. So we just need to sub our values in that we know to calculate the height above the orbital radius. Then we can get the height above the surface of the Earth. So let's put some numbers in. So g is 6.67 times 10 to the minus 11 multiplied by the mass of the Earth, which is 5.97 times 10 to the 24, divided by omega squared. So that's 1.08 times 10 to the minus 3 squared. And then obviously to get r, because that would be r cubed, we need to do the cube root. So that will give us an orbital radius of 6.99 times 10 to the power of 6 meters. So to get the height above the surface of the Earth, we need to do that orbital radius and subtract the radius of the Earth. So it's 6.99 times 10 to the 6, subtract 6.37 times 10 to the 6. So when you do that subtraction, we get 619 times 10 to the 3 meters, or a height above the surface of the Earth of 619 kilometers. So what I'm going to do is clear this and then do the final part, the centripetal force acting on the telescope. So part 3, centripetal force, is simply F equals mr omega squared. So the mass is 1.23 times 10 to the 4 kilos, multiplied by the orbital radius, which is 6.99 times 10 to the power of 6, then multiplied by omega squared. So that would be 1.08 times 10 to the minus 3 squared. And that would give a force of 100 kilonewtons. So hopefully that's helped with orbit style questions. Hope you've picked up a few techniques there. Well done if you got them right. And I'll speak to you soon. Thanks.